Hello and welcome to the Dinosaur Park YouTube channel. With a lot of people being forced to stay home and, well, not be able to come here to the park, we wanted to share some of our science experiments that you could do at home. So we've got here a little experiment that's going to talk some about how dinosaur bones preserve and what this can help tell us about those fossils. So we're going to bring the camera in here. So what we're going to need for this experiment is some sort of basin to hold water in, food coloring, you only need one color, and some sponges. So first thing we're going to do is fill this basin with some water. So with our basin filled with water, that's really all the preparation we need to do aside from just gathering the supplies. Now, before we start the experiment, we're going to talk a little bit about what this is showing off. This is going to demonstrate something called permineralization. Permineralization is one of the most common ways that dinosaur bones preserve. If we look at this fossil, is this visible on the camera? There we go. If we look at this fossil, you can see there's a porous material right there. You can also see right there some porous structure, and that's what bones look like on the inside. Now, that might seem familiar to you because kitchen sponges have about the same structure. That's why we're using them in this experiment. Now, the water is representing groundwater, because after a dinosaur dies, it often gets buried, or at least the ones that we find get buried after they died, and they get deposited into areas of water, but it's not nice, pretty, pure water underground. It's got a lot of minerals in it. That is going to be what the food coloring represents. Now, this experiment is going to demonstrate how these bones are preserving through permineralization. So, if we can point the camera back down, what we're going to do is, this is what in science we'll call a control group. Basically, it's a group we haven't done anything to, but we do it so that we can compare every other step of the experiment to it. So, if I put that sponge into some water, it's a wet sponge. I can squeeze it out, and it's a slightly less wet sponge. We're going to set that aside. Now, to demonstrate fossilization, I'm going to get green food coloring. Be careful with this one. I've already gotten a little bit on my hands. We wouldn't want to make a mess. And we're going to put just a little bit of green food coloring in there. And because I don't want to get any more dirty, I'm going to grab something to stir with. Grab just a little itty bitty piece of plastic, and we are going to mix that green around until we've got nice green water all over. Now for the second sponge, we're going to do the exact same thing we did to the first sponge. The only thing that we've changed is now the water is green. So if I douse this, we might want to pull the camera in even more. You see how that sponge is kind of greenish now? And I bet if I squeeze it out and pick up this, you can see especially in the green, in sort of the matte area, you get a little bit of a green tinge left to it. So we've got, I'm going to give this guy one more dip. Squeeze some of that moisture out. So we've got a kind of green sponge, but it's not really green. Now we're going to do something, which is, it's its own thing called capillary action. But it's important to paleontology, I swear, just stay with me. we're going to put only part of the sponge down. Now bring the camera in very close for this. You might even want to lower it. If we wait, you'll start to see the sponge is actually getting wet above the water line. As the sponge is absorbing water, it's pulling water farther up into it. This is really easy to see. If you dunk just a tiny bit of paper towel into some water, it'll suck up into the rest of the piece of the paper towel. And you can see, especially if I squeeze it just a little bit, I've got sort of greenish water, a green tinge there. See how it looks a bit paler? It's a lot of the food coloring doing that. Now, for a dinosaur bone, we're not just gonna dunk it into the water and pull it out. It's going, let's make sure we get our proper sponge. It's gonna sit in there and it's gonna stay there for, let's just say, 175 million years. Say it's a bone from the Jurassic period. So it's sitting there for 175 million years. As the organic stuff, the natural bone, starts to break down, just like these sponges are staying a little bit green when we pull them out of the water. Yeah, look at those two. Just like this sponge is a little bit green now that it stayed out of the water, that's because the green, or the minerals, is getting stuck inside of the material. Now this happens with natural bone, but the natural bone breaks down over time. And as it breaks down, these minerals that are getting stuck make a natural copy of the shape of the bone. So it's not just preserving the outside shape of the fossil, it's preserving the inside structure. That's why, with this fossil, we can still see the little holes in it, because the permineralization preserved all of that. So when something fossilizes through permineralization instead of mineral replacement, which is another common way that things fossilize, with permineralization we can learn a lot more about the inside structures of dinosaur bones. This was a quick experiment that you can do home. We've got a little bit of a longer format experiment too. Let me go grab some water for that. Now for this second experiment, it's nice and simple, but it takes a little bit more patience. We're going to need a cup of pretty hot water. Be careful with that. You might need a grown-up to help you with the hot water so that you don't get hurt. And then I've got here borax, but you can also use salt for it, and a little foam dinosaur cutout. This is the one I've got. He's already got some of this experiment going on, but we'll explain what that is in a second. So you're going to take your nice hot water and borax or salt, and we are going to pour that into the water and stir it around. We are using the hot water to dissolve this stuff into it, whether it be borax or salt. We're dissolving it into it. That way, it's got minerals inside of the water, just like the groundwater does, and just like what our food coloring represented. Now, I've still got a lot of flakes left there on the bottom, but most of the borax is now dissolved in there. And then, you're going to take your nice little foam dinosaur, drop it in there, and just wait. Now what's going to happen over time is the water in here is going to evaporate. The water just kind of turns into a vapor and then disperses through the air. But the salt or the borax that we put in it can't evaporate the same way the water does. So it gets stuck. And with our little foam friend in there, it's going to get stuck inside of all the little pores and holes just like it did in our sponges. Now, what can happen is over time, as these crystals start to build up more and more, we get, if I turn this guy around, we've done this experiment to him before. look at all those structures building up, starting from the inside of him. He's fossilizing, so he's a fossil dinosaur, he's just not a dinosaur that fossilized. Well, we hope you enjoyed our experiment. Hope you got to do a little bit of learning around the house. Feel free to stay tuned to our YouTube channel and subscribe to see more experiments and more learning that you can do at home. Thanks for